Hi everyone, my name is Trevlakis. I represent InnoCube and today I will present semantic communication demo that was developed within Task 4.4. In this scenario, we assume that a vehicle enters the campus and this vehicle has access to a digital twin service. It has the semantic encoder installed but not activated. It requests the activation of the digital twin service from the first base station that it connects, and then this request is forwarded to the task offloader that orders the activation of the semantic communication encoders of all nodes in close proximity to the vehicle. These nodes may be connected to one or more base stations, and in this specific scenario, the vehicle, a drone, and the roadside camera are identified. A request is sent to these nodes to initiate the semantic digital twin service. The left orange box designates that we have semantic multiple access, practically that we take advantage of data existing in different network nodes. The right blue box highlights the components that are deployed in the edge-to-cloud continuum. The triggered semantic communication encoders extract the semantic information from the video data and transmit only the semantic information to the base stations. And in turn, the semantic communication decoder receives the semantic information from more selected nodes and recreates the digital twin. The first version of the semantic communication component was created based on open datasets of two cameras that observe the same area. We apply object identification locally in each camera and extract the necessary semantic information. Then only the semantic information is transmitted through the network to the semantic decoder that creates a 2D top view digital twin. The objects by the top camera are shown in red, while the ones identified by the lower camera are shown in blue. Finally, we see that the objects that are jointly identified by the digital twin service are presented in purple. The main selling points of the semantic communication network that we propose is reduced network traffic, improved data efficiency, and improved energy efficiency. The network traffic allows us to release network resources to be used for other tasks. The data efficiency significantly reduces the transmitted data through the network, and the energy efficiency reduces the environmental impact of next-generation networks. In addition to this, some guidelines were extracted in order to be able to follow specific patterns and create successful semantic communication approaches. We need to clearly define the models in order to be accurate and in order to extract the appropriate information from the data that we want to transmit. We need to represent this semantic information appropriately in order to be explainable and to be able to identify if something goes wrong with a component. We need to minimize semantic noise because semantic noise can propagate errors to the communication channel and increase the errors in the communication as well. We need to incorporate redundancy in the development of the component in order to correct and detect errors and faulty capabilities. Interoperability is very important to be able to support a variety of devices, platforms, and systems. And finally, due to modeling of dynamic processes, we need to adapt over time and in different scenarios. Thank you very much for your attention. If you have any questions, I would be happy to answer them.